Hi, welcome to a EE140 problem solving tutorial. Today we'll be solving midterm 2A from Fall 19, problem number 1. Let's take a look at it. The electric field of a plane wave is propagating in a lossless non-magnetic medium with epsilon r is equal to 4. This is the given electric field. If we write out this given electric field, we can take a look at it and see any variables that we can take from the equation. From this equation, we can see the direction of the electric field. We can see that this omega is not given to us, so we may have to solve that later. We are given k, the propagation, so we know that that is equal to 400. We have a relationship between some of these variables, given as shown. Omega over k is equal to v is equal to c over n. C is the speed of light, and n is the index of refraction. The first question that it's asking us in this problem is, what is the frequency of this wave? We can find the frequency because we know omega is equal to 2 pi times the frequency. So if we solve omega, we can solve for frequency. So if we take what we know over here, we know that omega is equal to c times k over n. To find n, the index of refraction, we know that n is equal to the square root of epsilon r and mu r. But because this problem is in a lossless non-magnetic medium, we can consider this mu r to be 1. Therefore, n is equal to the square root of epsilon r, which is equal to the square root of 4. So n is equal to 2. Now let's plug in what we know, where n is equal to 2, k is equal to 400, and c is equal to the constant, the speed of light. So omega is equal to 3 times 10 to the 8 times k, which is 400, over 2. And the result for this omega is 6 times 10 to the 10. Plugging this in to 2 pi f, we have 6 times 10 to the 10 is equal to 2 pi times the frequency. So if we solve for frequency, we obtain 9.55 times 10 to the 9 hertz, which we can also say is 9.55 gigahertz. That is a solution for the first part. The second part of this problem asks us to derive the corresponding expression for the H field using curl cross E is equal to negative j omega times mu times H. We know that mu is just equal to this constant right here, 4 pi times 10 to the negative 7. Omega we solved above, where it is 6 times 10 to the 10. So after we do mu cross E, curl cross E, we can substitute those in. Curl cross E is defined as a matrix, 3 by 3 matrix, involving x hat, y hat, z hat, partial d dx, partial d dy, partial d dz. From looking at the electric field equation that we were given, we know that the direction, as mentioned earlier, was 2y minus 5z. There is no x component in this direction, so that is 0 right there. For the y, we see that there's 2y, so the magnitude is 2. So we can put 2 cosine omega t plus 400x minus pi over 8. Finally, for the z term, we have a negative 5z, so it is negative 5 cosine omega t plus 400x minus pi over 8. When we solve a 3 by 3 matrix, the end result will look something like x hat minus y hat plus z hat. So notice how that for the y component, it will be a minus in front of it after we solve the y component. So let's start solving each component. For the x component, there is no x direction, so it is 0. For the y, we need to solve because there is a y in this equation. To solve the 3 by 3 for the y, we will have to take out the y row and the first row, and we're left with the x row and the z row to make a 2 by 2 matrix. So let's take it. The new matrix, partial d dx, 0, partial d dz, negative 5 cosine omega t plus 400x minus pi over 8. That is for the 2 by 2 matrix that we obtained for y. When you do a 2 by 2 matrix, you have to solve it finding the determinant, which is AD minus BC, where it is as shown, A, B, C, and D. I wanted to quickly go over why we have x as 0. So if we draw the 2 by 2 matrix, we will have to take out the x in the first row, leaving us with the 2 by 2 matrix over here. If we do the AD minus BC for this matrix, we can see that AD minus BC, AD will have negative 5 cosine omega t plus 400x minus pi over 8 times d dy. However, we're doing d dy, right? But there's no y term in any of this entire section, so that is 0. Likewise, for d dz, we have 2 cosine omega t plus 400x minus pi over 8 still. It is still looking for a z, right? There is no z in this equation right here. So that is also 0. And as we know, 0 minus 0 is equal to 0. That is a clarification for why x hat is equal to 0. So let's solve the y using what we just showed you. Partial d dx times negative 5 cosine omega t plus 400x minus pi over 8. That is AD minus BC, which is d dz times 0, which is 0. Solving this is taking the derivative of negative 5 cosine. So negative 5, the derivative of cosine is sine, negative sine, so we put that negative sign there. Omega t plus 400x minus pi over 8 times the 400 that comes from the x because we're doing partial of d dx. The end result being positive, positive, so 2000 sine omega t plus 400x minus pi over 8 with a y hat, because that is the y component. How about the z component? So if we look at the matrix we made, we have to cross out the z and cross out the first row, so we're left with this matrix. That 2 by 2 matrix is as shown below, right here. Partial d dx, 0. Partial d dy, 2 cosine omega t plus 400x minus pi over 8. Now we do AD minus BC for this matrix right here. D dx that's for AD minus BC. This is also 0. So we're just left with this term. Solving this term, we obtain 2 negative sine omega t plus 400x minus pi over 8 times the 400 because of d dx. This gives us negative 800 sine omega t plus 400x minus pi over 8. And this is in the z direction. So, as I mentioned earlier, the result of the 3×3 is x hat minus y hat plus z hat. So we'll plug in what we have. It's 0 with the x hat here because it's just 0. So 0 x hat minus 2000 sine omega t plus 400x minus pi over 8. Why? Remember that this minus comes from there. Plus negative 800 sine omega t plus 400x minus pi over 8 in the z direction. So because this is 0, we are left with negative 2000 sine omega t plus 400x minus pi over 8. Y for the y term minus 800 omega t plus 400x minus pi over 8 for the z term. Remember that all of this was equal to curl cross E. And as shown in the given problem, curl cross E is equal to negative j omega mu h. So negative j omega mu h vector is equal to this entire thing. We can simplify this equation a little bit further because we see that these two terms are the same in both of the right side. The sine omega t part. So if we just combine the two, we get negative 2000 y hat plus 800 z hat sine omega t plus 400x minus pi over 8. All of this is equal to this still. We can now divide both sides by negative j omega mu, and we'll be left with h. These two negatives cancel out. So 2000 y plus 800z sine omega t plus 400x minus pi over 8 all over j omega mu. This j, however, we can treat it as 1 over j. If we multiply j on both sides, we get j over j squared is equal to j over negative 1. So that means 1 over j is equal to negative j. So we can take this j and move it up there and put a negative in front of it. So let's do that. Take out the j, put it up there, negative j, because of this right there. Now, negative j represents a phase shift. J is equal phase shift. We have a negative J, so that implies a negative 90-degree phase shift. We know that when we put a phase shift onto sine theta minus 90 degrees, it equals negative cosine theta. If we get cosine theta minus 90 degrees, we just get sine theta. In our case, we have the sine term. Since we have the sine term, we know that we'll end up getting negative cosine. So let's plug that in. We get negative 2000y plus 800z cosine, or negative cosine, I put that negative right there, omega t plus 400x minus pi over 8 over mu and omega. But let's start plugging them in now, because we already know from above that mu and omega's terms were as such. So 6 times 10 to the 10, 4 pi times 10 to the negative 7. Final result is equal to negative 0.0265y plus 0.01062 z cosine omega t, but since we know omega, we can plug that in now, t plus 400x minus pi over 8. This is the final H field answer with the units amps over meters. Thank you for watching the tutorial, and I hope you have a good day.